on here. So last time we talked about putting symbols and wires and stuff down and drawing up a schematic. Let's do another schematic really quick of an actual project that you could build that is a power supply that fits on the end of one of these prototype boards. You can buy these, but we're makers, so we'll make our own. Let's have a look, see how these things are actually made. I took a caliper and I measured the distance between this hole here and this hole right there, and I got 42 millimeters, somewhat nominal. These are somewhat flexible, so if I'm off a little bit, I'm sure it'll still fit in there. You can see the way these holes on the board are set up. Let me scroll down a little bit in this browser window. If you look at the top of the browser and use this as a general gauge, after all, this is just a regular photograph, you can see that the center of these holes line up with the holes in the middle, or at least almost, at least in that photo. Depending on where you are in the board, they do look better or worse. So that's going to be some distortion in the image. So anyway, my point is, if you wanted to build a board that's stuck in these holes here and these holes here and some of the holes in the middle, we know that they're all aligned. Now, if you get one of these smaller boards, which is very common in various kits, sometimes they sell these adapters like for Pis or something, or even their own power adapters. If you want to make your adapter fit in these holes and these as well as the middle, in this board you can see they don't line up correctly. I don't know why. Somebody probably just screwed up when they designed this product. And I've got both kinds of boards. These little ones to me are not particularly interesting. You can't really fit much on it at all, especially if you put one of those Pi T-bone things that hogs up like this much of the board. So like the entire board is used just by that. Now, granted, you can set this next to another board and put jumpers over, but then you get this big mess. So I tend not to use these little ones. Keep that in mind, is the only reason I bring it up. Right now I'm focusing on these. It turns out the little ones and these big ones still have the 42 in here, and that's all we're going to do anyways. We're going to put pins on each of the outsides. It'll fit on either of these boards. I just wanted you to think about where we're going here before we get there. So I fired up KiCad. Let's create a new project. That's an existing, there we go, new project. Let's call this one 2044. Let's call this breadboard power. All right, so it made its own directory and put some stuff in here. Let's open up a schematic. Let's fill this thing out. I'm in the US, so I like this, and I'm going to call this title breadboard power. We'll fill in the other stuff later, no big deal. Well, at least we'll put the date in there. Fine, revision 1. There we are. So now we've got some stuff in the title block here, and we got the right side page. Okay, so now when I use this, I do things a little bit differently than some of the other videos I've seen out there. I won't say I do it differently. I guess I do more than the other ones generally I've seen do. So let's go ahead and place some stuff in here. This is a power supply, so I'm going to need a jack of some kind. Now, as you use KiCad, you'll start to recognize how they name things. There's a thing called a barrel jack, and it looks like it's got an alias of that. So anyway, a barrel jack. This is the thing we're going to plug our power supply into. Let me bring this up. I double-clicked it. So I've got the editor. Let's look at the footprint here. This is key. When you're designing a project that you're actually going to make a real PC board on, you got to concern yourself with where you're heading with the PC board. So what we want to do now is find the power connector, this barrel jack. They do have some footprints in here, and they do match. I recognize that the CUI is the name of a company that makes various connectors. Now, there's some surface mount ones. There's through hole ones. These are actually the same part with two different kinds of footprints. We'll get to that later. These slot style holes some manufacturers won't make. You would have to use round ones. So they give you one of each. This one here is cheap and simple and designed to fit into a round hole connector. This 102AH, I looked it up on DigiKey. So I'm going to use that part. I think it costs 79 cents. We'll see that soon enough when we get there. All right, so there's my main power jack, and because we're heading towards a PC board, we need to make sure we have footprints for everything. If you don't have one, you can draw your own footprints, but that's more work. That'll be another video. This one is going to all use existing parts that have footprints in the library that you get with version 5 of KiCad, which I think is a great place to start. We're going to throw down some voltage regulators. I did some shopping. Let me close this. Let's scroll down a little bit to this other window. I went over to DigiKey. There's the CUI part. I guess while we're here, I'm jumping around a little bit. See this DigiKey part number? Once you find something in DigiKey, I always want to say, highlight that, hit Control C. And I want to know what I used when I made my schematic and where I want to go get it. I want to make the thing. I just want to draw it. I want to really make it. So what I'm going to do inside here, you can add more fields. I'm going to hit this plus down here. It says field 4. I'm going to make the value be, that's my DigiKey order number. And I'm going to call the field DigiKey. And we'll see how this thing can be useful later. I'm going to go ahead and click Show right here for now. What this means is I want this field number 4, which I just renamed to DigiKey. I want it to appear in the schematic drawing. I can also hide it, and I can get to it other ways. If you do this now, you now have the annotation. You have the the part name, or the size or whatever, and now I have the DigiKey order number right there in my schematic. I'm going to get, like I said, I'm going to show them on purpose so that we maintain our context here. I also don't want to call it barrel jack. I mean, I could, but I'm going to go ahead and put the manufacturer's name for the product in there too. So CUI calls it this. DigiKey makes this relatively easy. There are some CAD packages that actually go directly to DigiKey and lets you search and grab the parts directly if you want. So now what I have is the annotation. I have the actual part name number or whatever, and the DigiKey order number. These are very similar in this particular case. That's not always the case with DigiKey orders. The order numbers. All right, so let's go ahead and put down a voltage regulator in here. It turns out, again, it helps to go shopping first. I chose to use these products from Diodes Incorporated. These guys here, these are 1117 regulators. A lot of people make them, but these particular ones, the AZ1117C, which is from Diodes Incorporated, if you open up the data sheet here, I'm very happy to see this. Not all 1117s say that you can use ceramic capacitors with them. That's not a big deal depending on what you want to do and how you want to build your product. The other ones would require an electrolytic or a tantalum capacitor. Tantalums have their own problems. The fact that this manufacturer directly supports low ESR ceramic capacitors is a benefit to us, and they cost about the same anyway. Even in quantity 1 pricing, it's 39 cents. So here's a 3.3 volt and a 5 volt version. Let's go ahead and put in the 5 volt part number and come back over here. Now, they're not going to have an maybe they do, AZ1117. Oh, look at that. Oops, if I spell it right. 1117. They don't have the C in there, but they certainly have most of the product name in there. So I'm going to put a 3.3 volt guy down here. And then I'm down here, I'm going to grab the 5 volt version, AZ1117. Oops. Right there. Because I want to put a 3.3 volt and a 5 volt regulator on my design. Now, this is fun. This is a generic number, but the very specific one, the C and so on, this guy is what I really want to put in my schematic. So I made it clear to makers out there that want to look at this, maybe they want to reuse this design, what I really am putting in there. So you don't have to guess when you go over to DigiKey if you want to buy one or something like that. Here's your 3.3. Oh, while I'm in there, let's go ahead and put the DigiKey order number in there. Why not? Where did I buy them? Which ones did I use? Hit the plus. Say DigiKey. Field value. And oops, edit. Highlight the DigiKey field. Hit show. Hit OK. Now I've got all 3 on there. Again, this is a little messy, but I'm doing it on purpose right now for ease of understanding. Notice that somebody that made this part for KiCad put this link in here. If you go here, it won't work. So this is one of the reasons I don't use the datasheet links. People always change their websites and mess them all up. And if you do that, then you're stuck. Oh, I don't want caps. You'll notice that this case matters when spelling matters, when you decide to report all these items. So the DigiKey part number for the 3.3 volt regulator is on this screen over here. Copy, paste. Now let's go the footprint, no, the value of this guy. Manufacturer part. Oops, did I get these backwards? Hard to talk while typing. No, this is the manufacturer's name, and the other one is the DigiKey name. Okay, now we're good. You'll notice there's an extra space at the end there. Sometimes that drives me nuts when I cut and paste out of a PDF. Okay, so these are both done, and oops, I forgot to hit show on the DigiKey field, so now we can see everything that's going on here. Move this guy down here, right? Alrighty. So now I got my two regulators, and because I can use ceramic MLCC capacitors, that makes it easier to put together, and it actually makes it cheaper. So I'm going to... Now the way these things are supposed to work, a generic capacitor, is you put a capacitor on the input and the output fields of various sizes. So let's look at the input capacitor. I went down to DigiKey and chose in part based on price. Well, there's the connector. We can go ahead and put the order number of that in there if we haven't already. There's a 22 and a 10 microfarad capacitor that we're supposed to put on our design. So I chose to use these. These are 0805s, and they're 17 cents and I don't know, like 20 cents or something, like 38. You know, when you get up to like 22 microfarads, that's a pretty expensive, fancy thing in a ceramic form. So they do cost a little more if you get large sizes. Value. This is, well, the value is 10 microfarads. The DigiKey field is going to be the DigiKey number, and I grabbed the wrong one. I want this guy. Copy. You could put this part number in there as well if you wanted to, but we actually don't care that much about the specific part like we do with the jack. This capacitor, let me edit it again and turn on this field. I keep forgetting to do that. So now we can say move it over there so I can see what I'm doing. Maybe I'll move the whole thing over here. We got plenty of room on this page. Move this guy over here. All right. This part over here is very specific, and other manufacturers probably don't have the same footprint or anything, so it's critical that you get this part for this design. It's not critical that we use this exact part. This is more an FYI. Just get a 10 microfarad ceramic, and by the way, you can use this one if you want. Is kind of what I mean when I'm saying that in the schematic. Copy this and paste it down here now that I have all the good stuff in there. And make another copy and put it over here because this is where the output capacitor goes. We'll edit this. This one's supposed to be a 22 microfarad according to the applications of this guy, right? So go into here. It's not. This isn't a video about design per se. By the way, the part that I chose has this package here. We'll talk about that when we get to the footprints. Here's your design. This is the schematic. I'm drawing two of these with a barrel connector. This is the entire design. I'm going to just copy it right out of here. All right. Just so again, so you see where we're going here. All right. So there's my 22 microfarads. Now I need to change this number here. I can edit the whole part, which you've seen me do before, or I can double click on this line right here. I'm going to delete it right now and then go get back to my DigiKey page. Where's that part? This is the 22. It's the, oops, is that the output or the input capacitor? Oh no. The output is 22. Okay, perfect. This is the 22 microfarads, and there's the part number for it. I'm going to put that right there. And now I'm going to copy this down here. Again, put some stuff in here before you copy it, then there's less things to edit later. What I should have done is set the footprint before I copied it as well, but that's okay. All right, so we're roughly, almost done. We now hook up the various wires. I didn't line this thing up right. So I'm going to hit this thing, by the way, and I'm going to hit K right here and just end it. Hit escape, hit M to move it, and I'm going to bring it up like that so I can connect it. Oops, I can also see I didn't quite get this. So I can hit G, drag that over like that. So now that's connected up. Let me grab another wire and do this one on here. So this one looks good. And the input is going to come from this guy here. I'm going to, well, we don't need to really move this guy around. Let's go ahead and just connect from here over to the, now what we're going to do is kind of come down around here and hook up the other one. And then we're going to come in here and hook it up like this. That looks pretty good. This is the ground side. I'm going to hit K to end the wire without having it go somewhere. I'm going to hit escape. I'm going to go get myself a ground. This one is the one I generally use. Put them over there. Hit escape. Let's go some more wires. Just run all three of these across there and run all three of them across. Oops. This one needs to be moved. I want those to be able to line up, make it look pretty. Go across here. Go across there. Fine. Now I'm going to hit escape and hit C to copy this ground. Put them here. Oops. C again and put one up here. I missed this guy. Hit G. Oops. It doesn't know what I'm supposed to do, but I'm going to grab the wire and do that. Right? You've seen that before. I'm going to hit Control S to save this since the schematic is almost done already. What are we going to do here now? I want a power light on here. I want to see that it's turned on. So let's go ahead and put an LED on there. I like this one. Okay, so what do we do? Which way does the LED go? The arrow points from a high voltage to the ground in order for it to light. You also need, when you have an LED, you want to put a resistor in there. Regular old R symbol. Hit R to rotate. Hit escape. I can hit, remember, I can hit W. I can go right here and hit W and start drawing a wire. I'm going to hook it up to the 5-volt output. I'm going to connect it across like this. I'm going to copy this with a C, drop it over there, go right here, hit W, connect up the ground. 5 volts with an LED. I'm going to move the sizes around in this thing here. I'm going to hit E, and I want to edit the symbol as a whole. I want the value of this. I'm going to put a 1K in there. I can't stand it when people put LEDs on that are so bright it burns my eyes. This is a nominal size. Put whatever you want in there. A lot of times people put 330 ohms. If it's too bright, put a bigger resistor. You know that game. All right, so what do we want to do here? We need to go now find an LED for our project. I went into DigiKey and found some cheap ones. LEDs, for some reason, are insanely expensive. Somewhere in here I've got a LED that I picked out. Where is it? These are the various boards. Oh, there we go. Here's an LED. There's a nice diffused green one. I don't like the single point eyeball burners. So I'm going to go ahead and use this part. The thing that I'm going to notice is that it's a 3.3 millimeter round LED like this. Those have a 0.1 inch or a 2.54 millimeter spacing between those leads. That's the key. So we know how to, what kind of footprint we're going to use when we put it on our schematic. So I'm going to go over here and I'm going to hit E, and I'm going to go ahead and hit the data, put the DigiKey number in there. And I'm going to show it so everybody can see what's going on. We don't need to know it's an LED alt. I'm going to go ahead and say, make that field invisible. All right, just to clean up the schematic a little bit. This is a nominal resistor. The only thing you care about is to get one that will fit on the footprint on your PC board. So I'm not going to put a DigiKey order number on this one. You can just go find one. Now what do we got here? We've got all this stuff hooked up. Now we need to put some connectors on here so that it can sit on our PC board, on our breadboard. That's a connector. I don't like the way these look. I like what KiCad calls these generic ones that have this box on them like that. And I'm going to just use a 2x2, and you have different ways of numbering them when you have 2 columns. Do you want the numbers to go around like this? Do you want them to go back and forth like that? Do you want them to go, A and B? How do you want, that kind of thing? I'm going to choose this one where you've got 1, 2, and then 3 and 4 like that. Okay? Doesn't really matter. It's cosmetic for the most part. So I'm going to put that there. I'm going to hit C to copy it. And these things are generic as well, like a resistor. I'm not going to bother going and finding a digit key order number for that. Most people probably have these things lying all over the place. Just cut some pieces apart of some old parts you got lying around and make yourself a strip that has a 2x2 type of setup in there. Now I'm going to wire it up like this, and you'll see why in a minute. Move. That's basically so that this is going to be the positives and the negatives, and your breadboard. This is, I guess, drawn very much like the breadboard would be sitting. The breadboard would stick out this way, and you need to have these 2 pins connected together and these ones connected together. I'm using a 4-pin because if you just put 2 pins in that breadboard, then what'll happen is it'll sync all the current for your entire project will just go through a single pin on each of the 5 and ground lines, and that's a little bit crazy in my opinion. That's too much. I actually like the way this came out up here. Why did that? I must have had it up more. So I'm going to move this down. Now you'll notice this thing is a little bit messed up. Sometimes you can grab this guy and hit G, and you do that. Now it's crooked. I don't really want to do that. Maybe I can hit G over here, and no, I can't. I'll just hover over this or select it like that and hit delete and just redraw it. It's faster in this particular case. So the other one looked nice when I did this. Go over here and hit M, move it up a row, M, move it out of the way. Get these things so it doesn't look too ugly. Then hook up the ground side. All right, so there we go. Now, Control S to save it. We can go to the PC board right now and we could run it, but let's go ahead and do the design rules. Real quick, run this. We should see, we're not annotated, close. All right, so we've drawn all of our parts, but remember these all have question marks all over the place. So you can just annotate them all at once if you want. And you can decide how you want it done. I want the whole schematic. If I already annotated some, keep them, and so on. The defaults are usually pretty good with this. Now you'll notice there's a J2, and it looks like J1 is higher than J2, so it got numbered in a weird way. I don't care so much about numbering. Sometimes you do. You might want to have all these be the 10s and all these be the 20s and stuff like that. Right now I don't care. That's up to you for cosmetic stuff. Let's go ahead and try the DRC again. We have 2 complaints. Pin connected, some others, but there's nobody driving it on 2 of these. So let's go ahead and close it and look and see what we got. There's these markers here, these little green arrows. What it's saying is that this component here, if you hover over this and hit Control E, you'll open up an editor that shows you the part in the library. And when you make a part, a symbol, you say this is a power input, that's a power output, and so on. You can declare what the pins all do. So the problem with this particular schematic right now, from the perspective of the design rule checker, I'm going to close this, is that this pin is of type power in, and it knows that it better be connected to something that is a power out. Well, the capacitor doesn't have that. This is probably marked as passive. So let's go ahead and hit Control E on this. These are just passive pins that says they don't really have a role because it depends on the schematic. So I'm going to close this. There's nothing that says power out. This connector here will probably also say passive. And yes, it does. So the problem with the design rule checking is, now you could just ignore this because we happen to know this is going to be our power source for both the ground and the hot side. But there's a special way to deal with that. If you go to this power guy here, you type flag, what happens is you can put one of these on there and it says, look, someone's driving this, shut up and don't worry about it. I'm taking care of it, Mr. Design Rule Checker. You don't understand. I'm dealing with it. So what I'm going to do is I'm going to move this over a little bit, and I'm going to put a couple of power flags right over there. This also will help somebody looking at your design. Oops, no, it doesn't want to fit. Ah! Okay, what do I want to put it? I could turn it upside down, I guess, and put it over here. There we go. Save it. Design rule check. Delete the markers. Start over again. Now I don't have any complaints. All right. This tells the other makers and stuff that look at your schematic that this is really where the power comes in and so on. Again, this is so simple. You probably would be best off just ignoring it and moving on. But when you do a big and complicated schematic, doing things like this and telling people where to get the parts is just way better than being a jerk and not doing anything. So let me hide this thing. Make the thing less ugly. Edit that field. Make it invisible. I'm just hovering over the individual fields and hitting E and editing the field as opposed to the entire symbol, which I have also shown you how to do. If you hover over the main drawing of it and hit E, you get the whole big picture here. And what I did there is that other menu is another way to click and unclick this button right there. All right, so save this. We're now at a reasonable design for an actual product that we could build and use in our shop. So next time, what we'll do is we'll make the PC board out of all this. If you like this video, feel free to give me a thumbs up or let me know in the comments section what you think. We'll talk to you later.